Okay, in this video I'm going to briefly introduce some terms that are used in Chapter 7, specifically Section 7.1. We're going to talk about networks. So, in this particular video, I'm going to define what a network is, and then I'm going to briefly talk about degree of separation, diameter, and tree. I probably won't mention redundancy in this video, but I'm putting it on the board just so you know it's an important term. And I will do a video about that too. So I'm going to define network. I'm going to briefly talk about these three things. And then I'm going to do probably a video on probably one video that covers both of these, another one that covers tree, and maybe one that covers redundancy. And I might make these two different videos, I'm not sure. But in this video, the main thing I want to do is define network. Network is just a connected graph. Okay, so we've talked about connected graphs in Chapter 6. Let me draw a picture. One of the things they talk about a little bit in this section and in this chapter, mostly in this section, is Facebook. Facebook is a type of network. LinkedIn is a type of network. Matter of fact, they made a movie about Facebook and it was called The Social Network. Let's say there's 4 people. These are the 4 people. They don't have names, they just have letters. They're basically vertices in the graph that I'm about to draw. Let's say A and B are friends on Facebook. That is going to be represented by an edge between A and B. Now in networks, sometimes they call these edges links also, and they call the vertices nodes. But probably I'm going to use the term edge and vertex a lot, but you could also say link and node. So an edge between 2 vertices, which these vertices represent people, represents that they're friends on Facebook. So let's say B is also friends with C. A and C aren't friends, and B is not friends with any of these 3 people. This is not a network, because it's not a connected graph. Remember, a connected graph has to have a way to get from every vertex to every other vertex. So I can get from C to A because I can go from C to B, then B to A. But if I'm at D, I can't go anywhere. So this is not a network. Now, if person B and person D were friends, there would be an edge between them. This is a network. It's a connected graph. And that's all a network is. A network's a connected graph. So connected graph just means that for all the vertices in the graph, there's an edge. There's a way to get from each vertex to each other vertex following a link or an edge. So I can get to C from D. I can go to B, then to C. I can get to A by going to B, then to A. So that's what a network is. Okay. Now, like I said, I'm going to make videos about these other things too, but in this particular video I'm going to briefly mention degree of separation. Okay, let's have a new graph where D and C are also friends. Okay, so our new graph looks like this. I need a drink. Our new graph looks like this, and remember what this is. It's people's connections on Facebook. So C is friends with D and B, A is friends with B, B is friends with D and C, so on and so forth. Okay, degree of separation means the shortest path between one vertex or node and another vertex or node. So, in other words, what is the degree of separation between D and C? So I'll just write degree of separation between D and C. Well, it's the shortest way you could get from D to C. Think of it that way. It's the shortest way you could get from D to C. Think of path lengths, things like that. Well, to get from D to C, you could go to B and then to C. That would be a path length of 2. But you could just go right from D to C. So it's the shortest way. So those are the only 2 ways you could go. You could go from B, you could go from D to B, then B to C. We're not counting traveling more than once on an edge, just like before. We don't want to go from D to B to A, then back to B, then C. We want an actual path, or I guess you'd call it a path. They don't really use that term in this chapter, but they do sometimes, but not officially. So you could go from D to B, then B to C, or you could just go from D to C. We want the shortest way, the shortest path. So this path had length 2, this had length 1. So the degree of separation between D and C is 1. What is the degree of separation between A and C? Well, there's really only one. Well, I guess there's more than one way to get from A to C. You could go A to B, then B to D, then D to C, which has a length of 3. Or you could just go A to B and B to C, which is 2. So you want the shortest one. So the degree of separation between A and C is 2. Alright. Diameter, so like I said, I'm going to make another video where I talk more about that. Diameter is the biggest degree of separation between 2 nodes in a graph. Okay? So it's basically how big the network is. So let's look. The degree of separation between A and B is 1. Between A and D is 2. Between A and C was 2. Between B and A is 1. B and D is 1. B and C is 1. In between D and A is 2. D and C is 1. D and B is 1. It doesn't look like there's anything bigger than 2. There's no 2 nodes that have a degree of separation of 3 or more. The biggest one is 2. So that's the diameter of this network. 2 is the largest degree of separation between any 2 particular nodes. Okay? Like I said, I'll probably make 2 different videos for those 2 terms. Tree. What is a tree? I'm going to make a video about tree, or trees, I should say. But I'm going to talk about it briefly right now, too. A tree is a network. I'm going to actually write these 2 things, their definitions are longer, so that's why I'm going to make another video so I can write out the definition and talk about it. Tree has a pretty simple definition, though. It's just a network with no circuits. Okay. Network with no circuits. What does that mean? Where's my eraser? A network with no circuits. What about this network? This is a network, but is it a tree? Well, remember, a circuit's like, I don't know, like if you're a track star, I think there's somebody on the track team in our class. Sometimes you call a lap around the track a circuit, or like it's a cycle, a circuit, a lap. This looks like a track, right? See, that's a circuit you could do. This is not a tree because it has a circuit. You can go from C to B, B to D, D to C. That's a circuit. So this is not a tree. An example of a graph that would be a tree, I'm going to erase something here. This, it's still a network. It's still a graph, obviously. But it's also a network because It's a connected graph. But it's also a tree because there's no circuits. So that's a simple definition of tree. It's just a network with no circuits. And like I said, we're going to talk about redundancy in another video. So a network is just a connected graph. Here's an example of a connected graph. This also happens to be an example of a tree because it's a network that has no circuits. So in the next video, I'll talk a little bit more about degree of separation, possibly diameter. There's going to be videos on all of them. I don't know if they're going to be in the same video or not.